Greetings to all our data practitioners, and thanks for coming to our session today on how to generate data value faster using ELT with Google Cloud. My name is Jason Davenport, and I'm a tech lead here at Google Cloud, focusing on how customers can best leverage technologies like ELT in order to build more value from their data pipelines. You may have seen us talk a lot about this, which is the gap between data and the value that companies can actually generate from that. While we talk a lot about things like the volume of data, the variety of data, the location of data, sometimes we forget to mention the number of things that we can do to actually change this using process and technology and upskilling all of our engineers to be able to do more advanced patterns quickly and at scale. What does this really mean? It means that we need to reimagine how we can effectively perform data engineering at scale using technologies like ELT and managed frameworks that can be provided by companies like Google Cloud. First off, let's talk about data engineering and how we can bring more software engineering best practices to that using managed frameworks. Second, let's talk about scale and how we can actually go through and scale the engineering function to do more effectively and quickly. What this really means is there are two groups of users that we are working for with this. First is users who are working from ETL to ELT, which we'll cover in a second. And then the second group is folks who are working with ELT today, but have to make their own frameworks and the toil and the cost associated with that. If we know ETL from what we've done in the past, we do things like taking data from a source, transforming it, and then loading it into a target. While this worked well for small data sources, it generates a lot of inefficiency and doesn't let us do things with the data warehouse that it does best, which is run transformations at scale. And in reality, what happens with this process is that we have to run it hundreds or thousands of times for all of our different objects, again, generating toil for the engineering platform and the engineering team to maintain. So, first thing we should do is shift to ELT. And what this means is that we can use purpose built tools for extracting and loading data, and then we can use our data lake or warehouse to actually push down the right transformations. Now, while some tools do push down, and that's great, what we want to then make sure of is that we can use a managed framework in order to do that push down operation. And by doing this, what we're doing is we're not having to source our own framework, we're not having to build it, maintain it, and do things like bug fixes in it, but that we're able to leverage the best frameworks that are out there and then build things very quickly to get to value faster. Things that we do need in a framework, though, which are very important to call out, is that the framework does need to be low code. So we do need to support users where they are, in this case, users who write SQL. We need to be able to support automation across both pipeline development and then deployment and then monitoring and management. We need to have the right data quality pieces embedded at runtime and not discovered after the fact. And last, we need to support collaboration and documentation so any user can get in and pick up something to do development on. In reality, what we're also doing with this is managing our portfolio as a part of a data ops lifecycle. So let's talk about Dataform and how we're reintroducing this today to help you manage the transform processes that you do in your ELT lifecycle. Dataform helps us define tables, configure dependencies, test our data quality in real time, manage the code associated with all of this, and then orchestrate our pipelines at scale across our platform. What we can do here is really empower teams to collaborate quickly using software development best practices, allow data analysts to support the data engineering effort to build production grade SQL pipelines, and at the end of the day, or ultimately, have the right transformation pipelines that are built using straight SQL and don't have additional dependencies or other systems that need to be executed for those code pieces to run. With that also is that we now have an end-to-end data transformation experience within BigQuery. So today, and what we'll demonstrate is how you can get started using the open source SQL-based framework language for Dataform. We'll also do a quick preview of what's coming in Q3 for our web development environment that's integrated with Git. And then last, we'll talk about how we will be able to deploy this using a fully managed serverless process using Dataform in the web with its environment and scheduling management. All right, on to the fun stuff. Let's briefly talk about how SQLX works and how we can use this to build multiple development pieces. First, if you look at the top, we have a config block. This config block allows us to do things like assign the type of object that we're going to create, a table, a view, a materialized view, or an incremental table. We can use tags to define how something should run and which group it should run as a part of. We can do things like basic data cataloging, so having a table description, having column descriptions that make it easier to interact with our data from a user perspective. And we can also do things like run data quality tests right as a part of the config block. Last, we have our SQL statement at the bottom. So based on what we defined in our config block, Dataform will pick how this should best be materialized. In this case, because it's a table, we'll physically materialize the columns that we've selected below. And as you can see, we're able to use reference links, which allow us to link to other SQLX configurations to create a dependency graph that then Dataform can go and execute for us on our behalf. What this means is that we're spending our time here generating value with select statements and then just doing a couple simple configurations in order to get the data where we want it. Once we have that SQL statement, as we can see here, Dataform will take that along with the config, compile it into SQL statements that will be executed against BigQuery, and then we'll either have tables that are materialized, views that are created, or other operations that can be performed just within BigQuery and have those executed on a specific time frame or with a call to the Dataform API. All right, let's get started today. We're going to do three things. First, we're going to write a pipeline using SQLX. Next, we're going to add some assertions to that data in order to test our data quality and add data catalog attributes. And then last, we're going to actually deploy this code to an environment and get it running, all within the matter of a couple minutes. So first, in order to build a pipeline, we're going to create a new set of SQL objects, and we're going to check those objects into version control. This will allow us to have a pipeline that can be executed downstream in order to create business value. For this set of our demonstration, we'll be creating our initial project in Dataform, commit some code to it, and then make sure that we have all of our pipeline definitions in place for our different objects that we'll be creating. Here, you can see that I've pulled up my Visual Studio Code interface, and I've installed the NPM project for Dataform down here at the bottom. On the left, you can see that I've created a repo, and I've seeded it with a few different pieces of information. Let's go ahead and step through each of those, and then we'll go ahead and add some more code to this for our table definitions. First, I've added a dataform.json file. This is a simple file that just tells Dataform a few different things that it wants to do here when we actually execute some runs. First, I've specified the type of warehouse that I'm connecting to, which is BigQuery. Next, I've specified a default schema and an assertion schema. You can add a number of different other configuration things from the Dataform interface, but for this example, we'll just use these two so we can have our assertions or our testing that we create loaded to this schema here, and then use this if we don't specify a schema anywhere else. Last, I've specified my BigQuery project that I'm going to be executing this data against here on line 5. Second is the package.json file. This just specifies any dependencies that we need when we run Dataform here. And in this case, I've specified the latest release, and I don't have any other dependencies that I need to load. All right, let's go ahead and start creating our sources objects here. When we create sources objects, these are simply dependencies that then we can reference as we go along in our process. First, we'll create a few different objects here. I'll go ahead and I'll add a file. And what this file does is says that I'm going to create a table called badges. And I'll go ahead and paste in my config block here. You can see that we're going to pull data from the BigQuery public data project. We're going to pull from the Stack Overflow dataset, and then we're going to get the badges information here. And I've added another description that will be loaded to the table when we create it. I'll go ahead and create a few more ones here just for example's sake. All right, next, let's go ahead and create some additional objects. Because these are already physical tables in BigQuery, I'm just going to start creating some views on top of this to do some light data work to it. Here, you can see that I'm going to create a staging table for badges. So let's go ahead and create that. And what we can see here is that I've been able to call the reference of the badges object that we've created from sources. And then I can start doing some things like column casting, maybe do some simple cleanups like typecasts or those sorts of things. And then I'm going to actually materialize this as a view. So I'm not going to physically bring this data into my data set. Let me go ahead and correct this file name. And then last but not least, what we're going to do is we're going to actually commit this code. So now it will be checked into my repo for others to use going forward. Here, I'll just use this quick extension for us to do this work. I'll go ahead and stage all my changes, add my commit message. Let's go ahead and check this into our source control. Here we can see I pushed my code, and now it's on the main branch in my repo for us to move on to our next step. Great. Now that we have our pipeline created, let's move ahead and start to build in some assertions in order to test our data quality. First, we're going to add standard data quality tests to our objects, and then we're going to create some additional tests that we know just based on the business logic and add descriptions to our data. By the end of this, we'll be able to ensure that our data is measured for quality that can be assessed during each pipeline run. Let's get started adding some assertions to the different objects we've created. While you're away, I went ahead and added a few more objects for us to be able to materialize all of our data from source to reporting, where we'll look at some aggregate stats about different things like posts and user statistics. While we've created these different reporting objects here, you can see that we're actually doing some joins and some other unions from other references. What we want to do is also add some testing to this to make sure that our data is indeed what we're expecting when the user actually looks at this object. There's two ways we can add assertions. First one is using some default ones that are provided to us via Dataform, and the second one is being able to create our own. For this object, posts combined, let's go ahead and add just a quick assertion for us to test for the unique key. In this case, what we'll do is make sure that we don't get any duplicate post IDs, which may mess with our metrics that we'll look at later. I'll go ahead and save this object. And now we'll go on to our next one, which is the user stats. For this one, we'll add a couple assertions to this. First, you can see that we've added a unique key to make sure that we don't have any duplicates of users in our records. But the second one is we've actually added a special row conditions clause. And what this means is that if we see anything where the badge count is greater than or equal to 0, we'll know that we might have something wrong with our data and that we need to go back and look at how we've materialized this object here. I can simply go ahead and save these. You can see that these are a different color just because they're existing objects where we'll be merging this data in. I'll go ahead and, in my messages here, add assertions, stage my changes, and then I'll go ahead and commit them to my source repository. And it's as simple as that. We've added our assertions to these objects, and now we're ready to move on to our next step. Now that our code is ready to deploy, let's go ahead and actually deploy our pipelines to production. In this process, we'll actually create a deployment process using Cloud Build, and then we'll use that process to deploy our code to our environment. At the end of this, we'll be able to run our developed code in our environment and see our results. For the last phase of our work, we're going to create a way to deploy our code using Cloud Build, and then actually deploy our code to our project. For this step, we'll be creating 2 more files, and then we'll be able to actually run this as a repeatable process, and then also call this using things like Airflow from a container or something else in order to run our code. The first thing that I'm going to do is to create a simple shell script which allows us to deploy our code using Dataform. Here, what I've done is simply done a step here that will create a container, install Dataform, which means taking this repo here and packaging that up, and then we'll execute all the steps in this code. Next, what I'll do is I'll create our specific step to actually execute the Cloud Build build. Here, I'll create a new file called cloudbuild.yaml. And then I'll add my step here, which will tell us to run Dataform. There are a number of different ways that you can build Cloud Build scripts, but in this case, I've just used the YAML format, and I have a single step here, which is to run Dataform. If you wanted to run this for, say, in a production lifecycle, what you could do is simply schedule Cloud Build and then have this execute at a given cadence, say at 9 a.m. every day. You could also take this as a trigger from something like Airflow and then run this as a container as a part of an operator step. It's as easy as that. I've got my changes here. I'll go ahead and check them in. Oh, yes, let me go ahead and stage those. And I'll go ahead and push them. And now let's do our last fun part. Let's go ahead and actually run this. All right, I've gone ahead and set my project, and let's check to see which directory I'm in. We can see that I'm in my Dataform directory here. All that I need to do in order to actually make this something that can be deployable is I run a simple gcloud builds submit. All right, now we're ready to actually get this code up into our cloud environment. For our last step, all that we need to do is open a terminal. And what I'll do is I'll do gcloud config to make sure that I'm in the right project. And now all that I need to do after checking the directory I'm in is run gcloud builds submit. Here what this is doing is it's packaging up all the code that we just wrote. It's submitting it to the service, and now the service is going to actually build the objects that we created. We'll get some additional stats here about what the different container steps are doing. In this case, you can see that it's pulling down the node image in order to actually execute Dataform against this. Once this is complete, we'll be able to check and see what our different code pieces are doing. And now that we see that our terminal here is complete, we can see that each of our different objects was created, our assertions passed, and if we move over to the BigQuery console, we can see that my objects have also appeared along with their data sets, and that I can preview the data in order to see what it was actually visualized. Last, if I ever need to come back and look at the history of that job that I just ran, I can come over, I can get Cloud Build, I can come to the dashboard, and I can actually see my successful build here and get all of my logging information back after I need it. In summary, we've been able to build all the different pieces and deploy our models, and then be able to trigger them in order to actually have our data get built. This is very simple for us to get started with Dataform, and I encourage you to get moving today. I love doing this demo because it's super easy to see how all this comes together so quickly using SQLX and Dataform. Now let's talk about what's coming here in Q3, and we'll do a quick bonus peek here. Let's get into the UI and we can see how much the authoring experience will be improved using Google Cloud Console. Here we are in the next version of Dataform powered by Google Cloud. Just like we did in Visual Studio Code earlier, we'll be able to connect to existing repositories or create new repositories, manage our branches as a part of our Git structure, and then dive into definitions of objects that we'll be creating or staging using Dataform here within the UI. In addition, if I open one of the existing definitions, we'll be able to perform all of our different authoring things like we did in Visual Studio Code, but with the benefit of seeing the metadata that this configuration will actually create and the queries that would actually be executed if we were to run this as a part of a workflow or as a part of a broader set of workflows or tasks. Last, we can commit these changes and execute our different Git steps with this, And we can actually execute this, which means that we could just run this as a part of our daily tasks or something else. So this object would be created. This will be a great way to get into Dataform without needing to do the additional steps of developer-based configurations to actually use Dataform going forward. All right, go ahead. Let's get started working in Dataform. We have the link here to using Dataform from the github.com repository for Dataform. Go ahead and clone that and get writing SQLX. We look forward to hearing from you on our Google Cloud channels, in Stack, and in our other collaboration points. Thanks again for attending our session and looking forward to sharing Dataform with you more here in 2022.